Today we will be going over Geometry Chapter 2, Section 3 of the Big Ideas Math Common Core High School textbook. So our essential question is, in a diagram, what can be assumed and what needs to be labeled? So here are 7 more postulates involving points, lines, and planes. So I would just stop the video here and kind of read through them and get a sense of what each of them mean. So let's move on to some exercises. After reading our postulates, we can directly use this with our problem here at hand. So we have A, if, and then we have 2 lines crossing each other, then, and then it's the same image but just with 1 point. So if we look back at the previous slide with all of our postulates, we can automatically see that this visual representation is really similar to the one in the problem. And if we read it, if 2 lines intersect, then their intersection is exactly 1 point. That correlates to this problem. Next, when we look at B, we have 2 planes intersecting each other, and then we see the same image, but there is a line showing at their intersection. So let's look back at the postulates again, and it's going to be this one again because we can see the image, it's very similar to each other, and we can read it, and it says if 2 planes intersect, then their intersection is a line, and that's exactly what the picture is depicting. So here are the answers. Next, sketch a diagram showing line TV intersecting segment PQ at point W so that line segment TW is congruent to line segment WV. So we can our first step is to draw TV and then label the points T and V. Our second step is to draw point W and the midpoint of TV. And then you're going to want to mark the congruent segments with the 2 tick marks. Step 3 is draw PQ through W. And this is your final product, what it should look like. So next, which of the following statements cannot be assumed from the diagram? If we remember back to the postulates we just covered, we can easily answer all of these questions. So if I were you, I would also just look at the postulates while you're solving this problem. So just pause here before I go over the answers. So points A, B, and F are collinear. That would be yes. As we can see here, A, B, and F are all on the same line, so they have to be collinear. Points E, B, and D are collinear. This cannot be true because there needs to be a line connecting all 3 points, but if we look here, E, B, D, there is no line here, so we cannot assume that. For this one, number 3, line AB is perpendicular to plane S. This is true because if we look at a line AB and plane S, we can see that there's a 90-degree angle that is formed from this line to this plane. Number 4, line CD is perpendicular to plane T. This is not true because if we look at line CD and plane T, we need this 90-degree mark, but since we don't have it here, we cannot assume that. Finally, line AF right here intersects line BC at point B. And yes, we can assume that because the intersection of 2 planes is always a line. In this case, it is line BC. There's another line running through point B, which means that they both intersect each other. In other words, they are sharing a common point. So again, for these problems, we have to find out which postulate is illustrated by the diagram. So for number 3, we would use a 2-point postulate, which is that through any 2 points, there exists exactly 1 line. For number 4, we can use the plane point postulate because a plane contains at least 3 non-collinear points, which is exactly what is shown right here. So first, A, B, and C are coplanar. Let's look at the diagram. A, B, and C. And yes, we can deduce this because they are all on plane T. Next, plane T intersects plane S in line BC. So this is line BC and plane T intersects at this line. And yes, we can deduce that because we know that the intersection of 2 planes is always a line, and that's exactly what line BC is. It's the intersection of these two planes. So we know that this is where plane T intersects plane S. Line AB intersects line CD. So this is line AB and this is line CD. And we cannot deduce that because if there was a point here connecting these two lines, then we would be able to say that it does connect. However, that's not the case. H, F, and D are coplanar, and we cannot say this or assume this because we have here point H, point F, and point D, and we can see that they are not on the same plane. So point H can be both on plane T and plane S because it's the intersection point. However, F can only be on plane T, and D is only on plane S. Plane T is perpendicular to plane S. So this is plane T, this is plane S, and as we've already concluded, they do intersect at this line. But in order to conclude if they are perpendicular, we know that we can because there is a 90-degree mark that shows plane T is perpendicular to plane S. Point B bisects segment HC. So we have point B and segment HC. And we do not know that. The only time we can conclude if it bisects this line is if we have those congruent marks. But since we don't have those congruent marks, we cannot conclude that. Angle ABH and angle HBF are a linear pair. And if we remember back to what a linear pair is, it is just two angles that form 180 degrees or sum up to 180. So we have angle ABH right here and angle HBF right here. And we can conclude this because as we can see right here, this is one extending line. And since these are two adjacent angles, they will make 180 degrees. Another name for this is supplementary angles. Finally, line AF is perpendicular to line CD. So line AF is right here and CD is right here. We cannot conclude this because we don't have the 90-degree mark to show this. So please do this exercise again and then just pause the video and then resume as I will be discussing the solutions. So in order to determine that M is the midpoint of AC and BD, the segments would have to be marked congruent. And the ones that would have to be marked congruent are AM and MC, and then DM and MB. But based on the diagram, the congruent marks are not in the correct places in order to say that M is the midpoint. Rather, AC and DB intersect at point M such that AM is congruent to MB and DM is congruent to MC. But we cannot conclude that M is the midpoint, and we also can't conclude that AC intersects BD at a 90-degree angle because we would need that 90-degree angle to show it. So think of examples on your own, and I will be discussing possible solutions that you might have gotten. So for number 5, this postulate is a line contains at least 2 points. So we can see here that line P contains points H and point G, and then another one you could have done is line Q contains points G and points K. Number 6, line intersection postulate, which is if two lines intersect, then their intersection is exactly 1 point. So in this case, if we take a look at line P and line Q, they intersect at only 1 point, and that is point H. Next, 3-point postulate, which is through any 3 points is exactly 1 plane. An example of this is that through points J, point G, and point L, there is only 1 plane, and that is plane M. Finally, plane line postulate, which is if 2 points line a plane, then the line containing them also lies in the plane. So point J and point K lies in plane M, which means that the line containing them, which is line K, also lies in plane M. Also, point H and point G lies in plane M, so line P would also lie in plane M. So here's our last problem. Choose the correct symbol to go between the statements. We have the number of points to determine a line on one side and the number of points to determine a plane on one side. So thinking back to our postulates, we know that the number of points to determine a line will be 2, and the number of points to determine a plane will be 3. So therefore, this will be a less than sign. Please like and subscribe if this video was helpful and you want more content on the following geometry chapters. Thank you.